Hello friends, and today our topic is combination of errors, also known as propagation of errors. Today we're going to see how can we estimate the errors in the sum, difference, product, quotient, and the power of different measured quantities. We shall deduce the general rule for evaluating errors in a combined calculation. But what do you mean by combination of errors first of all? An experiment involves survey measurement, and the final result is arrived at using different physical relations. The error in the final result depends on the individual measurement as well as mathematical operation done to get the final result. The following rules are used to evaluate the maximum possible error in a measurement. So first we have error in the sum of two quantities. Okay, so let delta A and delta B be the two absolute errors in A and B quantities. So what this basically going to convey to us is that we have two quantities A and B, and they can have delta A and delta B, two errors with them. Okay, fine. Then so we can have let Z be equal to A plus B. Some number, the sum of both of them, let it be Z. So of course even Z will have some errors, so it can be delta Z be the error in Z. Fine. Then, and now the real solution starts. This is the introduction part, introducing the error part and the real true value as well as the think of it. So if you're saying let A and B with the true value and delta A and delta B with the errors, then what will be the measured value be? So the measured value in such case, measured value of A would be A plus or minus delta A, isn't it? Because it can be minus or plus, we don't know about it properly. And delta A, okay. Second is measured value of B would be B plus or minus delta B. So that's how you have it. Simple introduction, and that's the main part is. So let's have Z is equal to, so let Z is equal to A plus B, okay, which means Z plus or minus delta Z is equal to A plus or minus delta A plus B plus or minus delta B, isn't it? Yes, because see, A and B, they are just the true value, isn't it? If you want to find the measured value, how it's going to be. So okay, fine. Opening up the bracket on the right hand side will give us A plus or minus delta A plus B plus or minus delta B. Can we take this together one side to give us A plus B? Okay, so plus and minus delta A plus or minus delta B, and here we're going to have Z plus or minus delta Z. And as you have said in introduction part that Z is equal to A plus B, so you can simply cancel this part out because this means the same thing. Okay, now we have plus or minus delta Z is equal to plus or minus delta A plus or minus delta B. Okay, so what all possibility can we have here? Talking about this case, you can have it either as plus A plus B plus A minus B, then minus A plus B, and minus A and minus B. And same thing will go on changing for this case also, but we want the maximum possibility, isn't it? And that will be, so our maximum possibility you're talking about so far will be when they all are positive. So maximum possibility for our first case would be delta Z is equal to delta A plus delta B. Very simple, yeah? So what this whole thing means, so trying to find out the error in a sum of two quantities, that is, we're adding two different quantities such as a measured value, and we have to find how much of maximum error they can have possibility. So now we understood that if A and B are the measured value, then the original value will be A and B also, and they let them have error delta A and delta B. In such case, you have taken Z to be the sum, and even the Z will have an error because we're adding of the measured value. So you can have delta Z as its error in it, a change in its error, and with that steps you have got the answer. Great. Next you can see the error in difference of the two quantities. Okay, so look at it then, difference of two quantities. Before we do that, let's conclude our first error. You can conclude it as, hence the rule, the maximum possible error in the sum of two quantities is equal to the sum of the absolute error in the individual quantities. Okay, simple as that. And second, we have the errors in the difference of two quantities. Let's have a look at that. Now for difference of two quantities, consider again a and b as two quantities such that z is equal to a minus b. Make sense so far? Okay, now you will also have some error in them. Let it be delta a, delta b, and delta z. So giving us z plus or minus delta z is equal to a plus or minus delta a into, in the whole bracket, minus b plus or minus delta b. Okay, so far clear? So understand, we have minus of this. This time we're going to change as you open the bracket out. So let's see how it changes. So it's going to be z plus or minus delta z is equal to a plus or minus delta a minus b. Now if you see over here, we have minus and here plus and minus. This is going to be, just look carefully over here, it's going to be minus plus delta b. It's very important to make this difference, even though it means the same thing, but it's important to show the difference that you know how it has been done. Okay, so what happens is minus and plus becomes minus and minus just becomes plus. That's how it is being formed over here, but they both mean the same thing, but you have done it to show the difference between the change after minus is coming between there. Similarly, as to group these two things, how you group for other one becomes z plus or minus delta z is equal to a minus b. Okay, plus minus delta a minus plus delta b. Okay, you can cancel this because they are mean the same thing we have shown already here. Great. Now what is left with us is delta z plus and minus and plus and minus delta a minus plus delta b. Now similarly, we need to find the maximum possible error, isn't it? So what is our maximum possible error in this case also? It's the same like the before one. You can have the maximum error when everything is positive. So giving us delta z is equal to delta a plus delta b. So in simple term, whenever you have to find the difference or the sum of two quantities with errors provided in them, you have just used the simple formula. That's it. So, but you need to know how it's been derived because they're going to ask an exam sometime for derivation of it also, how it has been done. So for now you have seen so far sum and difference. Now let's see the product and quotient, and last one the power of a quantity. Now how do we conclude this one last step? How to conclude it? Let's conclude it as we have done for everything else. So we can say, hence the rule, the maximum error in the difference of two quantities is equal to the sum of the absolute errors in the individual quantities. Same like our sum, but just is how its form is different. Okay, so similarly, you're also going to have the same final answer for product and difference, but you're going to find it in different way because they are different two things. Yeah, so let's have a look at that also. Now let's see the error in product of two quantities. So let a and b be two quantities such that the measured value of a is equal to a plus or minus delta a, where a is the true value and delta a will be our error. Okay, it will be plus or minus. Similarly, measured value of b, let it be equal to b plus or minus delta b. Fine. Talking about product, let us have z. Let z be equal to a into b. Okay, so far clear? Now if z is the product of two quantities, two measured quantities which has error, which means even z will have some error in it. Yes, makes sense to it, which means let z have an error called delta z in it. Fine. So we're going to have now z plus or minus delta z is equal to a plus or minus delta a into multiplication. Yeah, so b plus or minus delta b. Fine, clear. Now be very careful when you open this bracket up, because multiplications you must know how to open brackets. Let's see how to open the bracket on the RHS side. Let's see then. So you're going to have this to be as a into b. So a into b plus or minus a into delta b, same as it is. This with this one now, plus and minus b into delta a, and then plus or minus delta a into delta b. So if we have talked about this, we can also represent the product with a dot, like in this case. Simple, yeah? Okay, fine. So now what next now? Now what we can do is we can take out the AB outside. We can move the AB outside. So we can just take out the AB outside. So you can take out Z outside from here, giving us this way. That is Z taking out outside becomes 1 plus or minus delta Z by Z. Simple? Yeah. Okay. Similarly, when you take out AB outside from this section, it's going to give us 1 plus or minus A into delta B divided by AB plus or minus B delta A divided by AB plus or minus delta A dot delta B as into divided by AB. So you have got these two things. Now I can cancel this easily because they are equal. Fine. Now I have done this thing so I'm able to cancel these two things. Now you might say to me, why don't you simply cancel it over here? Even that makes sense, but that won't give us correct output which require. So as you're gonna see in the next step how I'm going to proceed further. Okay, now what to be done? If you see carefully on this side, you can find out that we can cancel some terms, like we can cancel A, but we can't cancel this because this is delta B and this is B. We cancel B over here and there you go. Simple, yeah? So now we can have the answer as 1 plus delta Z by Z is equal to 1 plus or minus delta B by B plus or minus delta A by A. And now here we have plus and minus delta A into delta B. Okay. So scientifically it has been proven that this product, that is delta A into delta B divided by AB, give you a very minute answer, because imagine for yourself, the error would be very small, isn't it? You can, let's say the error produces something like 0.02 for example, and same thing for this, and multiplying those two numbers to give you more smaller answer, and dividing by AB will give you much smaller answer. You can see when you calculate in a normal general practical way, you find the answer of this to be very small, so we neglect the value. Because very small, we can get something, let's say something like 0.000. It goes on. So it's like too small compared to this value which is get. So you can ignore this. You can neglect it. So hope it's clear to you how we can remove this out. Because see, imagine for yourself, delta and delta B are the errors, and normally if you see errors are very small, and multiplying errors with decimal will give you more smaller answer. Okay, and dividing by AB will also give more smaller answer because AB is more bigger number, yeah. So when you divide a number, let's say 2 by 7, won't you get a small answer? Of course you get, because 7 is greater than 2. So that's how it should make sense to you. And so you can neglect that last number, because the answer will be very small compared to what you have given here. If you see, you can cancel 1 and 1 on both the sides to give us now plus or minus delta Z by Z is equal to plus or minus delta B by B plus or minus delta A by A. Simple? Yes. Okay. Now we want maximum possible error. That is possible if we have all the terms are positive for us. So now we can say therefore our maximum possible error is possible when everything is positive. So you can have delta Z by Z is equal to delta A by A. Okay, it's again order wise, and B by B. Very simple. That's the answer, and that's it. You're going to get the same answer for quotient also. We're going to do in a bit different manner because we have division in that case. So let's go through one more time, understand how it's been done, how we're able to remove the bracket from this right hand side part, and how do we neglect this part, and all those things. Now moving on to the next one. Before that, let's have conclusion for this part. So hence we can say that the maximum fractional error in the product of two quantities is equal to the sum of the fractional error in the individual quantities. Great, yes. The fourth one we have is error in the division or the quotient. Let's have a look at that also. Okay, now let's do the error in quotient division of two quantities. It's a very simple like product, but let us move on now. So let us again have Z is equal to A divided by B. Simple, yes. You can have errors to it. So you can have like this way: A plus or minus delta A divided by B plus or minus delta B. And like in Proto, you can take out the z and a by b outside in a very simple manner. It's going to be z divided like this way, a plus minus. Okay, so a 1 plus and minus delta a by a is divided by b plus and minus b by b. Hope it's simple to understand. Now moving on, what you can do next is we're going to again simplify this more further for calculation. It's going to be a divided by b, as per you know what is it supposed to be from here. Okay, and we're going to have 1 plus and minus delta a by a. We're going to take this to the numerator area to give us 1 plus and minus delta b by b and whole raised to minus 1. Now how is minus 1? You know very well, because if you have a number, let's say 1 by 10 like this way, so this can be written as 10 raised to minus 1, isn't it? Because taking it towards up direction, so come minus 1. The same thing having done over here also. Okay, now you can cancel this up, giving us 1 plus or minus, delta z by z is equal to, before opening the bracket, we try to convert this into proper form like how we have here. So how is going to do with that? This will be as 1 minus plus delta b by b. Because the sign is changing, understand how it's changed, okay? Minus and plus, okay? Now let's open up this part to give us 1 into 1 is 1 minus plus delta b by b. Similarly, plus minus delta a by a. This becomes minus, okay, because 1 into minus is minus. Again plus, like that way, minus the same thing, into delta a by a into delta b by b. Like before, understand the point that this value is going to give us very small, so you can just neglect this value actually. Okay, so just neglect this value at all. Okay, fine. So this is cancelled to give us again the same result like how we had for product, where you had to just find out the maximum error. So now as you can see clearly, our maximum possible error would be what? You know it very well what it's going to be. It's going to be, z by z is equal to delta a by a plus delta b by b. Simple, easy, smooth, and very simple steps, isn't it? Yes. Okay, that was for our division or quotient. Let's conclude this whole step into simple conclusion line. Hence, the maximum fractional error in the quotient of two quantities is equal to the sum of the individual fractional errors. Great. Last we have is error in the power of quantity. Very important one, okay, because this is the most common question in exams. So let's have a look at it. Let's consider the nth power of a. Now what this means, when I say nth power of a, I simply mean to say that z is equal to a raised to n. Simple to understand, that we have some number like how we had z is equal to a plus b. Similarly, we have z is equal to a raised to n. So they're going to have some error in them, so you can give us z plus and minus delta z, okay, is equal to a plus and minus delta a whole raised to n. Now how is whole raised to n? It's very important to understand the point. Okay, and because, for example, let's say we have x is equal to a plus b, for example, okay? So if we write x raised to n is going to be a plus b whole raised to n. It's the same thing being used here, because a is nothing but the measure value, yeah? And measure value is equal to the absolute, is equal to the true value plus or minus the error. So which means it's going to give us a plus or minus delta a whole raised to n. Great, yes. Moving on now. So here you're going to be using a small binomial theorem part. It's very simple actually. I'm going to tell you what the theorem is and how to apply it also for this specific problem. I can learn more about binomial theorem in class 11 mathematics chapter. And it's very easy, I feel so. But let's move on with our problem here. Next, what to be done? So like in our product and quotient, we can take out the z and a raised to n outside from here. Let's see how we can do it. This would be z outside 1 plus or minus delta z by z. Okay, that's simple. Now what about this area? How do we do this one? Okay, let's understand. Fine. This would be a raised to n 1 plus or minus delta a by a whole raised to n. Remember saying how is that possible? Let me tell you how is possible. Let's see how is that possible. Okay, fine then. You have a plus and minus a delta a whole raised to n, isn't it? Can I write this also as in a very big bracket like this way? I have n over here. I take out the a within inside to give me 1 plus and minus delta a by a. Makes sense so far? Clear? This is what we have done actually. So when I just open this up, I can just write this as a raised to n into 1 plus and minus delta a by a whole raised to n. And that's how we arrived at this conclusion. Hope it's clear. The same thing, let's make a bit bigger bracket over here. And here taking the a within the bracket, within the whole raised to n bracket. And after that, let's remove it and just have it up as it is. So hope it's simple. I have understood how it's arrived. Let's move on now. So no need to write down this extra step which I've shown you how it's been done. I've just shown you to understand how I've come to the conclusion of a raised to n into 1 plus or minus delta a by a whole raised to n. Okay, now fine. Great. Now can we cancel this both? Of course we can cancel them. Okay, so far clear and steady. Now we shall be using up our binomial theorem for this given part. Let's see what is theorem and how do we use it. The binomial theorem says, binomial theorem, oops. Okay, fine, let's see. It says 1 plus x whole raised to n is approximately equal to 1 plus n into x, comma, where x is very less than 1. So it's equal to this one. This is basically the whole thing all about, where x is very less than 1. Okay, I hope it's clear so far now. Fine then. That's what is it basically. That's the formula. That's it. So now how do we apply it over here? Very simple. We have got logic so far, and this is basically binomial theorem we have learned for our physics classes. But for math, you have something more to understand, but you can see that later. But for now, moving on, we have 1 plus or minus delta z by z is equal to, so 1 is 1 itself, plus and minus because I have that over here. Now this set n is power n into x. What's x? Our x is delta a by a. Simple. Hope you understood how it's been done. Because see, the theorem says 1 plus x whole raised to n is approximately equal to 1 plus n into x, where x is less than, very less than 1. Because you know delta a by a will give you very less than 1 because delta a is the error which is going to be lesser than the value of a. Yeah, so when divided, you're going to give very less number, a small number. So this satisfies our condition. So we are using binomial theorem to get us 1. Okay, same way plus and minus n into what's our x, delta a by a. Simple, yeah. Now cancel a on the both the side. So we come to a conclusion of this one. As you can see here, plus or minus n into delta a by a. Okay, now we need to use we need to have the maximum possible error, which is provided by our what? Provided by our plus on all the side, our positive, yeah. So therefore, you can say now the maximum possible error is what? It's going to be delta z by z is equal to n into delta a by a, and that is our answer. Very simple, yeah. So when we have an error in power of a quantity, we use this formula to find the answer. Okay, great. So let's conclude this also with our statement. The statement says the fractional error in the nth power of a quantity is n times the fractional error in that quantity. As you can say, n times the fractional error in that quantity. So here I come to the end of our first video on physics, talking about units and measurement chapters, important concept of combination of errors, and hope you understood everything I've taught you so far. And if any doubts, any confusion, any questions about this concept, any other concept from this chapter, let me know down in comments below so I can reply to as soon as possible and clarify your doubts and confusions. And always be curious and learn physics with interest. So with that, signing off, so this is production.